Welcome back, everybody. It is Mrs. Pound, and we're talking about Chapter 4.2 Work and Energy. And today's topic is going to be forms of energy from Section 4.2.2. So, our objectives for today's video are to identify various forms of energy, explain the transfer of energy in a given system, and calculate kinetic and gravitational potential energy. So let's first talk about chemical potential energy. This is stored in the chemical bonds that hold atoms together in molecules. And some examples are gasoline, wood, food, especially from plants, and batteries. Now, in the background, we have food. We also have some meat, but the animal that was killed for its meat got its energy from plants. So that uh, energy from the sun is initially stored in plants for food. There's also elastic potential energy. This is stored in a stretched spring or other elastic object. Some other examples are rubber bands and a diving board. There's also gravitational potential energy. This is stored in some object that has been lifted to some height. So this boulder up here, this has a lot of gravitational potential energy because you can see that it is high up there at the top of that canyon. So there's also a formula we need to know for gravitational potential energy, and that is mass times acceleration due to gravity times height. So PE equals m times g times h. So a example of a question you might be asked is, what is the potential energy of a 10-kilogram box sitting on a shelf 2 meters high? So first thing we do is write our equation, PE equals m times g times h. Then we substitute in our numbers. The mass is 10 kilograms, acceleration due to gravity, 9.8 meters per second squared, and the height is 2 meters. And when we multiply all of those numbers together, we get 196 joules because remember, energy, the unit for that is joules, the same as work. Another form of energy that we often use is electrical energy. This is the kinetic energy of electrons moving. DVD players, the blenders, and power tools use electrical energy. There's also radiant energy from the sun. An example would be light. There's also mechanical energy. This is the total potential and kinetic energy within an object or body. And an example is motion. You can see there's a lot of kinetic and mechanical energy going on here with these rides at the amusement park. There's also a formula you need to know for this, and for mechanical energy, it's the same as kinetic energy. Kinetic energy formula is 1/2 times the mass times the velocity squared. So K equals 1/2 times m times v squared. So an example of a problem using this equation would be if a half-kilogram ball is thrown at a speed of 4 meters per second, what is its kinetic energy? So first thing we write down is our equation, K equals 1/2 times m times v squared. And then we fill in the numbers. So we put in 1/2 kilogram for the mass and 4 meters per second for the velocity or the speed. Now don't forget we have to square this, so that becomes 16 meters squared per second squared. Then we multiply what's in parentheses, and that becomes 8 joules, and then we have to divide that by 2. So the answer is 4 joules. Remember, joules for energy, just like for work. So, what about a wind-up toy? A wind-up toy is able to walk because the mechanical and kinetic energy of the hand turns the key and created elastic potential energy. So, energy conversions here, mechanical and kinetic to elastic potential energy. As the key unwinds, the elastic potential energy is converted to mechanical and kinetic energy that is transferred to the legs so the toy can walk. And finally, let's talk about the transfer of energy in a swinging pendulum. There's a lot going on here, so make sure you fill in these values. and let's talk about them. So, at 90 degrees, all of the energy is potential energy and there is no kinetic energy. So, let's say you pull the pendulum back to 90 degrees. Okay, so you've pulled it up to 90 degrees. Obviously, it's not moving yet, so 0 joules of kinetic energy, but it's at its maximum for potential energy. And I don't give a number here because it depends upon the mass and the length of the string, the height, basically. So I don't include numbers here. I'm just saying it's at its maximum. Now, as the pendulum swings down, okay, at 45 degrees, which is halfway here, I don't have it labeled, but at halfway, the energy is converting. It's converting from potential energy to kinetic energy, and it is half potential and half kinetic. Then at 0 degrees down here, all of the potential energy has been converted to kinetic energy. So kinetic energy is at its maximum, potential energy is 0 because it's all the way down. Now, I don't have any more things, but that's because any more slides. That's because the trend goes back the other way in reverse. As it goes up here to another 45-degree angle, it's half kinetic and half potential. And then as it goes back to 90 degrees, it's back to 0 kinetic energy and maximum potential energy because it stops for just a split second too before it starts to swing the other way and the cycle continues back and forth. So, our objectives today were to identify various forms of energy, explain the transfer of energy in a given system, and to calculate kinetic and gravitational potential energy. So, don't forget those 5 questions, and I'll be back with more about work and energy.